Here we are, all done with section 1, part A and B. No more multiple choice. Woo, that's nice. So we are going to start the 2016 Calc AB exam, practice exam. Section 2, part A is the first 2 of 6 free response questions. All right, for these ones, thank you, we get a graphing calculator. We are just going to do free response question 1. Like the video now. Come on, you know you want to. You can. No harm in that. The video will still keep playing. That's fine. But follow me, more importantly, because when you follow me, that is when you will get notifications when I put up videos for free response question 2, free response question 3, and so forth. But if you like the video, that helps me personally. Following me helps you. Liking the video helps me. So let's do a little give and take here, friend. And let's start free response question number 1. Number 1 reads, a company produces and sells chili powder. All right. The company's weekly profit on the sale of X kilograms of chili powder is modeled by the function P, okay, given by P of X equals 48X plus 1.4X squared minus 0.05X raised to the 2.8 minus 270. Weird how they wrote that, but we'll take it, where P of X is in dollars and X has an interval inclusive from 0 to 80. All right? Let's find the rate in dollars per kilogram at which the company's weekly profit is changing when it sells 32 kilograms of powder. All right, let's start to figure out what they're asking us, okay? Find the rates, okay? Well, okay, P is profit, all right? P is profit, okay? And X is kilograms, okay? So they want the rate in dollars per kilogram, okay? Which means if I have P and I want the rates, that's one derivative away. So I'm going to find the derivative of P of X for that first statement when they tell us to find the rate in dollars per kilogram when it sells 32 kilograms. So I'm only going to find this at 32, all right? And don't forget, we get to use a calculator for problems 1 and 2. So I am definitely going to use the calculator for this one, all right? So let's solve that, and then afterward, it says, is the company's weekly profit increasing or decreasing when it sells 32 kilograms of chili powder? Give your reason. Increasing and decreasing, that's like slope, right? I would have a positive first derivative if it's increasing, and I would have a negative first derivative if it's decreasing. So once I find that first derivative at 32, I'm just going to look at the sign. Is it positive or negative? And that's how I'm going to answer that second question. And give your reason, well, you know, we'll just state it nice, short, sweet, and to the point. So let's begin. Oh, calculator, how I love thee. So I'm going to take my calculator, and first I got to turn it on. And then we're going to go to math and pick choice 8. Okay, and my variable is X. I'm going to put my equation in there just as it's given to me. 48X plus 1.4X squared minus 0.05X raised to the 2.8. Okay, every time I type these in, I'm looking to make sure I didn't miss anything. Okay, minus 270. Okay, there it is in all its glory. I'm going to double check this. 48X plus 1.4X squared minus 0.05X raised to the 2.8 minus 270. And I want that derivative, excuse me, when X is 32. There we go. So I will drag this out here so that we can see it. All right? So back here, you know I love the calligraphy pen. Let's continue this. P prime of 32 That's all I have to do to let them know how I got this number. I put 32 in the derivative of P is 65.92, and that is dollars per kilogram. I'm going to do that because that's what they're asking me here, so why would I not write it? Okay, and there you go. That's the answer for the first part. Is the profit increasing? And give a reason for your answer if it's increasing or decreasing. So I'm going to say, since P prime of 32 is greater than 0, I could have written, since P prime of 32 is positive, that's fine. I just like doing inequalities. The profit is increasing. There are one of a million different ways I could have written this. But if I just have the number and not this statement, identifying whether it's increasing or decreasing and explaining why, I don't get full credit. Easy problem to start with. 1A, done. 1B, how many kilograms of chili powder must the company sell to maximize its weekly profit? Okay, so I'm going to look at my equation for profit, and then it says justify your answer, so we just need to show the work that led to our answer. All right, max, mins and maxes. We want the max here, okay? I need to find the critical point where the first derivative of x is equal to 0. And then I'm going to put on some number line, okay? If this is 0, I want to make sure that it's plus to minus. I want to have a positive first derivative to negative. That would show me a maximum, okay? And how many kilograms? X is the kilograms, and P is the profit. They want to know how many kilograms. I'm going to look for the X value, okay, so where it happens. What value of X is this going to happen? Now, let's keep in mind that first derivative is also the same thing as slope. So the slope of P of X is the first derivative. So if I want to find where the slope is 0, okay, I just look at P of X and see where it has a horizontal tangent line. I can literally use the max function in the calculator. That's going to be the easiest way to do this. I mean, hey, they let us use the calculator, so here we go. It's going to be a lot easier than trying to make that derivative equal to 0. I tell you that. So let's turn this on. Okay, let's go to y equals, and let's put in our equation once again. 48x plus 1.4x squared. I'm sure you guys are thrilled hearing me speak it as I type it. Minus 0.05x raised to the 2.8. That exponent just gets me. Minus 270. Now, I know this window is going to be something crazy, so what I'm going to do is I'm going to change my window, and I'm going to go from 0, because I can't have negative kilograms. And let's go to, I don't know, 100 by 10s. Okay, and y, 0, profit's got to be more than 0. I go to 1,000. And let's go, actually, let's go to 3,000. And we'll go by 1,000, which means I'm only going to see 3 tick marks. I'm going to graph this. This is P of X. Okay. Oh, right there's the maximum. Then that's doing some funky little dive down. All right. So this is P of X. The derivative is a slope. Where's the derivative equal to 0? Right here. Okay, it's a positive slope, so my slope, or first derivative, is positive here. My slope, or first derivative, is 0 right here. And then my slope, or first derivative, is negative here. So it does go positive to negative. That is a max point. We just need to find the x value at that max point. Okay, so let's do this. Let's go to second trace, and let's find the maximum. Okay, I'm going to enter on the left side. go all the way over to the right side, hit enter, and then hit enter one more time. And there you go. We see our maximum x value at the bottom here. Boop. Let's bring this right here. Here we go. So that happens at an x value of 58.3. Oh, we can call that 358. That's fine. We can call that 36. It doesn't tell us where to round to. So as long as you round either the second or third number and it's correct, I'll go two numbers, 36, and that's kilograms. Okay, but where's our justification? I suppose I can sketch this graph, all right, and then make an arrow here that says, 58.36, comma 2893. Sorry about that writing. Okay, or, all right, I can really do a number line. I can say the first derivative equals 0 at that 58.36. Put it on a number line. I'd rather draw the graph. Okay, at 58.36, my first derivative is 0. If I pick the number 50, we know it's going to be positive. If I pick the number 70, it's going to be negative slope. So there's a maximum right there. Okay, we can do that. But on my answer key, I actually did both. Okay, I actually did both because, the grading on these things, it really chaps my buttocks. I do this, I do this, I do P of X, and I do some sort of, it doesn't have to be, not, precise. I do this like here. Maximum. There's a max at 58.36, comma, that's my x value. And then we said that was 2893.0, ooh, is it a 4? Okay, and then I go positive to negative slope. Okay, so I'm just that type of person. Okay, it doesn't say explain, it just says justify. But if I wanted to explain, obviously you should know I have a positive slope leading up to my 0 slope. Then I have a negative slope after that. And that's how I know I have that maximum. We're good. C, the company plans to have a one-day sale on chili powder. Oh, glory be. Management estimates that T hours after the company store opens, chili powder will sell off the shelf, no doubt, at a rate modeled by the function S. And that is given by S of t equals 2 plus the cosine of pi over 10 times t squared. Kilograms per hour. That, my friends, is a rate. I know this is a rate because it's kilograms per hour. And, oh, by the way, they tell us it's a rate. Okay? So based on this model, estimate the amount of chili powder in kilograms that will be sold during the first 5 hours of the sale. Two things that are critically important. First off, if I have kilograms, which is a unit, and then I go to the rate of kilograms per hour, right? Kilograms per hour. Going this way is derivative. But I have this and I'm going back. They want to know the kilograms, and they give me this. I integrate. Okay? So I'm going to integrate S of t, I don't know why I wrote 2 sets of parentheses, I'm thinking the calculator maybe, dt. What are my bounds? This is the second thing you need to know. The first 5 hour means from time 0 to time 5. 0 to 5. This is good. I was about to say we haven't integrated yet, and now we do. On your paper, you can write it like this. That's fine, because you're telling them you're integrating this equation. Obviously, in the calculator, you got to type it out. So now that I'm done writing that enormously long equation from 1a and 1b, with that exponent that was 2.8, it was just weird. All right, I'm going to quit this, and I'm going to go math and pick 9 for integration. From 0 to 5, I want 2 plus cosine alpha y equals enter of pi over 10 times, I've got to use x instead of t, squared. I'm going to write it just like they gave it to me. The t squared, in this case the x squared, was not in the numerator, it was just off to the side. I'm not going to leave anything to chance. My variable is x. I hit that. And I get 11.4328. We'll call that 11.43. Okay, we'll just keep it here this time. I typically always round to the thousandths, but if they don't tell me, I'm going to round to the hundredths. As long as your rounding is correct, you're good. That is 11.43 kilograms. Because remember, this is what they want. They gave us this. So my answer's in kilograms. Bam! I like to do some integration, especially when we have that calculator. D, 1D. This is the last one for 1. This is the last part of 1. Problem 1, 1D. Using the function s from part C. Okay, so I'm just going to do this right here. I mean, you don't have to on your paper, but s of t equaled 2 plus cosine of pi over 10 times t squared. Okay, this is s. Using this, okay, find the value of s prime of 3. I mean, we could use a calculator. I got to find the derivative at 3. Interpret the meaning of this value in the context of the problem. Interpret. I better write something down after I get a value. So let's go here, boom, and let's go math 8 this time. X variable, 2 plus cosine alpha y equals enter of pi over 10 times x squared, where x is 3. Negative 0.582. Okay, negative 0.582. I know last time I rounded to the hundredths, now I'm rounding to the thousandths. Okay, negative 0.582. Negative 0.582. Now, it is the derivative of a rate. This rate was, if I go back here, kilograms per hour. So if this was in kilograms per hour, this is in kilograms per hour squared, or kilograms per hour per hour. Okay, we tend to write it more like this. All right? So it's my rate that's changing. It's not just the kilograms. Okay, I'm not going from kilograms to kilograms per hour. I'm taking my kilograms per hour, and that is changing. All right? So let's be specific. And I want to go back to something where I wanted to tell you to be specific. Can I go to 1A just for one moment? We'll come right back here. If I didn't say this. In any explanation, make sure you are specific. Don't just say the derivative of p is greater than 0. Make sure you put at 32 because that's what they're asking about. Okay? So let's go back here to D, and I'm going to be specific. I'm going to start off by saying that 3 hours, okay, at 3 hours into the cell, meaning we're into the cell right at 3 hours, okay? Cells of kilograms of chili powder, well, I should say the rate, oh, not the rat, the rate of sales of kilograms of chili powder will decrease at negative 0.582 kilograms per hour. And then if you want to do squared or, you know, but kilograms per hour. All right? There you go. This is changing at this rate. Okay, we're done. I love y'all. I do. Was that enough to make you like the video? I hope it was. I really worked on that in the mirror last night when I was talking to myself in the mirror last night at home. But I wasn't alone at home, so just don't worry about me. Just like the video and follow me so you can get more notifications of when I continue this test and when I put up more new AP Calc exam work. For now, have a good day. Bye-bye.